She's a mentor, she's a text expert, she's an international speaker, and no matter that you looked all tiny, cute, and all that, she has a black belt in Taekwondo, so...
Fourth degree.
Fourth degree. I don't know what that means, but I think that's still black belt, okay? So be aware of what you're asking after the session, please. Debbie, stage is yours.
Thank you very much. So, we have the slides up, great. We have all tech issues sorted, great. This is like one of the first times this year that I haven't actually had to do it all myself, hope to press the record button, and then you record your talk and then you forget to press the button, something happened, and you got to repeat the whole talk. So it's so nice to be in person, be in normal life, have tech professionals set it all up. So this is great. Thank you all for coming. I appreciate you all taking time out of your life to be here. And for those that are online, thank you for waking up or whatever time it is in your day for being here today. So we're going to talk about a component-driven repo for a component-driven world. Now, what does that mean? I'm going to basically go through how you can build component-driven applications, what is component-driven, and how I'm going to show you how I did it, what I did, and hopefully then you might leave here and be able to build better software, or at least have an idea of how to do it so that maybe you can, in the future, want to do it. So, yes, I am a head developer advocate at Bit. My name is Debbie O'Brien, and everything that she said, so thanks for the great introduction. And basically, you can follow me on Twitter, Debs_O'Brien. So any questions you want to ask, and as well as all the support I do, I'm also a Google Developer Expert, a GitHub Star, a Media Developer Expert, and a Microsoft Most Valuable Professional. And this photo is actually taken at a tech conference in Antarctica. Yes, I'm one of the very few people who got the chance to go to Antarctica to give a tech talk on a cruise ship to the penguins. No, there were more people. But it was absolutely amazing. And because I'm on this stage now, and after I came back from Antarctica, the world just got locked up. So I was on one of the last ships before everyone else got stuck on the ship. So here's a couple of photographs of what Antarctica looks like. Just thought I want to share, just in case one of you think wow, I'd love to go there. I recommend it to anyone. It's absolutely the most incredible place on Earth. So this has nothing to do with component driven, but just that I'm on a big stage, so I want to share those photos. But yeah, it's absolutely amazing. And if anyone talks about climate warning and all that kind of stuff, I was there, I seen and heard the iceberg just break in front of us. So when they say the ice is melting, seriously, but amazing place. So let's talk about the web. The modern web is component driven, right? Basically, everything is moving into components. If you're working in, front end, anyone here in front end? Yes, lovely. Anyone back end? Lovely. Anyone full stack? Yeah, love it. Okay, cool. So we're covering everything here. And sorry about all you other people that are possibly DevOps and, data scientists, and then you're definitely in the wrong talk, but welcome anyway. Okay, but no, the modern web is component driven. So we're building applications with React, with, Next.js, Vue, Svelte. We're building in components. Testing is done in components. Everything is done in components. So, I don't need to talk to you today. You know what you're doing. We're living in a perfect world. Everything's great, right? Why are we even here? Why'd you come to this talk? Or are we? Is the world really perfect? This is what building apps in 2021 is actually really like. We've got all these developers. We're all thrown into that one code base. Our apps are scaling, especially because of COVID and what's happened. Now, all of a sudden, we need even more. We need more applications. Everything has gone to online. And we're hiring more people every day. And they're being thrown into this code base. And they're being told to just create more components, build more applications. And it just becomes it can be quite fun, but it's a little unorganized. So let's go back in time and take a look at, what it used to be and compare it to where we are today. So we started off with a big, massive monolith, and we had things like, jQuery. Yes. Who built in jQuery? Yes. Who's still building in jQuery? Oh, come on, please. And PHP, HTML, CSS, and JavaScript all stuck together in that one application. It could be Java, could be .NET, could be whatever. Who's still working with front and back end mixed together? Oh, you poor thing. Come and see me later. So we pretty much have a little bit evolved, except for that one guy over there. Everyone else has separated their back end and their front end, right? So this is great. This is cool. We've got the front end separate. They're doing their thing. The back end are doing their thing. And we're just communicating between each other and everyone is happy. Cool. Except that guy. And then the back end, they got all clever on us and they started building microservices. And they kind of basically took their big back end monolith application and went, ooh, we're going to have all these cool microservices. And then they did all that, which is really cool. And my artwork is not great, but basically that's what it looks like, right? So that big monolith is now these little kind of stones, and it's looking really cool. And what are microservices? For those of you that don't know, microservices arranges the application as a collection of loosely coupled services, so they're not all stuck together. It's split into terms of responsibility and knowledge. And they can have incremental updates, independent deployments for each service, much smaller code bases, so they don't have that big, massive code base to manage. And it's much easier to scale your service. And if you're a microservices expert, you could probably write better slide than this, but I'm a front ender. So these are the microservices. Back end have done an amazing job, but the front end is still a monolith. And it's kind of true, right? Now, as a front end developer, you're all sitting there and you're saying, yeah, but I'm building React applications or Angular or Svelte, and they're modern, so I'm doing everything right. So what am I doing wrong? I mean, we're all building modern. And this is the thing, that your components are very tightly coupled and nested inside your application. Because as soon as you build an application, you're building, for example, a React application, a Next application, Next.js, and you use create React app. It creates an application. And then what do? You build components inside that application. They're stuck inside the application. We don't build the components first. We build our application and we throw components in there. And then we have like this massive, thing, this application full of all these components. So basically, it's still a front-end monolith, even though it's inside a modern tech stack. We got one code base for everything. So we've got no team ownership. How do you separate inside that code base that this team is responsible for these components only? This team is responsible for this area. I mean, you could use code owners from GitHub, for example. It's one way, but it's not great. You've got one version for your application. You've got all these components, but the components don't have a version. The application has a version. And that makes it very hard to scale. And then you've got one build, because you're just building the application. You're not building a separate component, which makes it very slow to develop. So you've got to wait till everyone's finished building something, and then you're like, okay, now we're ready to push to production. And what happens when you want to scale to multiple applications? So now we've got 3 applications, and they're pretty much very similar. And you're using very similar components, right? So this is just a e-commerce application, you've got a shopping cart, and you have another e-commerce application, you've got another shopping cart. And how do you then share that component across those 3 applications? So you duplicate the component, don't you? I know you do. I can see you up there. Who duplicates their components? Yeah, thank you. At least we have 3 honest people in the room. I duplicate the components. It's just easier, right? Because if you got to do all the managing of packages and all the kind of things, it's just like too much. So it's easier to just take that code, copy paste it, put in the other repo, and bang, you've got a solution. And also, I mean, the code's never going to change, right? Like, we're never going to update the component. Like, it's a finished version. It's perfect. Yeah, that's what they tell you. So when you start duplicating your components, you have a lot of code to maintain. And you end up with a lot of inconsistency across your applications, because you are going to start to update one, but then one team is working on that component. They're going to update it. The other team isn't. And next minute, you've got a discrepancy between them. And then one app goes completely one direction, the other app goes another direction, and you have a complete disaster on your hands. And yeah, it's really hard then to start going back and try and update every single one of those components, especially as new teams come on board and your application just grows and grows. And then you're kind of just reinventing the wheel, right? So you're taking a component and you're just like, duplicating it, making another one and extending that one out, instead of actually just using one component across all those applications. Updating the components over multiple apps is time consuming. I know one company, it took them about 6 months to update their logo component across all applications and websites. Painful experience. You just want to update that one logo once, right? But no, if it's not a component, if it's in each of the other components, yeah, it's a lot of hard work. And you might say, well, we don't update our logo. No, but then you do cool things for like special, like Pride Day, and you put a Pride logo on, and then you do Christmas, and you put a Christmas logo on, you do another one. So we are actually updating our logos more often than normal. So then you might say, okay, well, let's just package our components. Let's throw all our components into a package, put it up in NPM, and then we can like just use it as a component library in every single one of our applications. And this is a great solution. I've used this solution. But then as your component library grows, you're now, taking that component library into all that applications with loads and loads and loads of components that you don't want, don't need. And you could package them all separately as well. You could say, right, I'm going to take every single component, the shopping cart component, the button component, every component, put it as its own independent package. And then you've got all these packages to maintain, which is very frustrating. It's a lot of package JSONs as well. I know there are tools out there that have made it easier, like, Lerna, for example, and that does help, but you've still got to manage those package JSONs. And you still have to update all your dependencies, which is a complete and utter nightmare if you've ever done this. Anyone used Lerna? Yeah, so you know the pain, right? Yeah, exactly. So it's a solution, but then you've all these components on NPM, and how do you discover it? A junior developer comes in and you say, we have 300 components on NPM. Go find the one you want and use it, right? NPM wasn't built for components, it was built for packages, so it's just not meant to do that. So that's when we all go to monorepos, right? That's a great idea. We have these, multiple applications. We want to share components, so let's just create a monorepo, right? And we have then everything in there. We don't have to package components. We can just share. It's easy. It's all done. And this is great, right? These are all our components stuck in this now one, basically, repo. And monorepos are pretty good, right? Because it improves speed. I can now access all these components very easily, so I can build a lot quicker. I can share code very easily. I can reuse the code in any of the applications. So this is pretty good. And I've got a good dev experience. I'm quite happy and quite quickly building things. So this is good. If I need to refactor something at a large scale, I can easily do it because I have access to every single one of those components. And cross-team collaboration is easy. So if I'm working with you and you're on the shopping cart team and I'm on the design team, we're very easily able to collaborate with each other because we're all in the same code base. And then we have like great standardization because our ESLint, we just have one of them. We have only one prettier file. So everything is on the same standards. So monorepos are great. Who's using monorepos? Just that one guy again. Now we have a few more. That's cool. Yeah, so monorepos are great. But monorepos also have a couple of problems. So with monorepos, the tooling, it wasn't really built for monorepos. So for example, if you've got a really massive code base, doing your git fetch, for example, can take ages. Cloning a repo can take ages. And there are tools, again, that are built to improve this, like code spaces from GitHub, which is really, really cool. And it's so much faster, and it's in the cloud, and it's another way. But we're not there yet, and not everyone that has code bases has accesses to it or is using it. In the future, maybe that will be enough. But right now, not everyone has that. Visibility and discoverability. Now, you might say, but you're just contradicting yourself because you just said it's easy to find things. Yeah. But when you're in a code base like VS Code and you want to use a component, you search for that component, right? And then you find the code of that component. But do you know what it looks like? Do you know how it behaves? Do you know where it's used so you can actually see it in action? So sometimes like discovering the component in the code base is not really the perfect solution. And it's really easy to break each other's code. And that's not great. Like, you have no idea who's using that component. So if you make a change to it, you have no idea how it's going to affect all the other components and what it's going to do. So yeah, you just start breaking each other and then you throw it into production and then it's like a disaster. And you're going to say, but I write tests. Yeah, you do, but do you? Does everyone write tests? Who writes tests? Okay, that's not bad. That's about 50%. So we're almost there, but 50% of you are going to break my code, so you are not coming into my monorepo. So onboarding developers is like very difficult because, we're onboarding developers all the time, and a lot of junior developers or new developers from completely different, code bases, frameworks, etc. And they're coming in and you're like, here's a massive code base, just go diving, figure it out for yourself. If you need help, give me a call. And that's pretty hard, right? You want a developer to just come in and just be focused on that one thing that they want to build. Maybe it's the shopping cart. You're going to build a shopping cart. That's all the code you need to worry about. If you give me the whole code of the whole company, it's a lot of code. And your builds are slow, right? Because you're building all those components in the application, etc. Now NX have done a great job at this, and they're like caching the builds and stuff. So it's a great tool. So that can help. But in general, if you're not using that tool, it can be very slow. And there's no team boundaries and ownership. Who owns what? You own this, and you should only touch this code, for example. Again, it's you could use code spaces where you say this team can only touch these folders, for example, and that's one solution. Google have a better solution. They say basically whoever breaks whatever code has to fix it. So then you're responsible. If you break something, you got to fix it. But yeah, there's not really a great team ownership. So I asked on Twitter, what do you love or hate about monorepos? I'm doing research for this talk. So who here actually likes monorepos? Okay, 2 people. Nice. Who hates monorepos? Okay, more, it's pretty much even. And who just doesn't care? Yeah, perfect. So basically, this is the answers I got back. And I got some great answers, right? I've only got experience in one, but we managed to end up in a situation where every consuming repo has to import every package in the monorepo. So we have the crappy tooling and bloats of a monorepo and none of the claimed benefits. And then Oliver said, he's a huge fan. He loves it. But the tooling hasn't helped, and solutions like Lerna were hamstrung by the NPM client's limitations. And then Brandon says he loves the shared code between apps libraries, the visibility, the collaboration, the consistency, and the ability to standardize a single package versions. So he knows what he wants, but he hates the insufficient tooling, which makes the experience bad and can lead to bloated CI times and lots of ad hoc scripts. So pretty much, if you look at everyone, basically, they all hate the tooling. The tooling is the problem. So we need to fix the tooling, and then life will be better. So the same goes if you're scaling one large app. So if you don't have multiple applications, and you just have one application that you're going to scale, you're still having the same problems, right? You still have that large code base with all those developers thrown in there, working together. It's still hard to discover components, even if it's just one large application. It's still hard to give teams ownerships. It's still working on one main branch. I mean, you can branch off to different ones, but you're still going to merge it to that one main branch. And there's no internal versioning of your components. And you've got one long build time. And you've got to manage then all multiple deployments of everyone, all these other teams, who having to deploy everything when they're finished what they're doing. So this is how we're working today, right? So how can we make this better? So what we need to do is break down the front-end monolith once and for all. We need to look at what the back-end have done with microservices, and we need to try and put that into the front end and see how we can achieve something similar. Now, first of all, what do we want? We want teams to own features. We want to be able to say, you own the shopping cart area, that's yours. You own the product, you own the support, you own, etc. And then if you own that feature, that's all you have to worry about. So here's my support team, for example, and the support team basically would own the request component, so the form that users use, so they own that component. And they could own the online chat widget, for example. They're responsible for developing that. And they own the support tickets. So that's a page component, as well as the support ticket dashboard. That's a big component, but it's still a component. So that team is responsible for quite a big part of the application, but that's all they have to care about. The rest of the application, they don't care. Then you have another team, that's the product team. And the product team could own the shopping cart component. Very important component, otherwise we make no money. the get product component, the hook, the product card component, so the widget, and then like the page, right, of all, the products. So the product team own all those components. That's the only thing they have to care about. They don't care about what the support team are doing. And then you got the design team. And the design team they actually work on components that both teams use. So they kind of have the smaller components, like the button component that's reused across the application. The card component that's used for the product card and could be used for other things in the support team. The logo, because the logo could be on multiple different places in the application. And they own the tooltip component. So all these kind of like smaller components, the design team own it. It could be base team or whatever you want to call your teams. So, very simple. You got your 3 teams, and all they've got to do is worry about their components. So the support team is going to build their components, and they're going to actually push them up to the support scope. The product team will push their components up to the product scope, and the design team will push their components up to the design scope. Now you're going to ask, what's a scope? So a scope, this is kind of cool, is like a next-gen microservice, allowing teams to own and expose APIs that include both front-end APIs, back-end APIs, and even node modules. Nice. Kind of big words there, but let me show you. So this is just all my scopes that I've created. And basically for everyone, so I've got a base UI scope, and they're like my button, my logo, my card component. They're all my kind of base components that are going to be used to compose the rest of the other applications. And then because I'm building stores, I've got an e-commerce scope, and that's where the e-commerce works. So that's going to have like, my product card, anything product related, shopping cart, all that kind of components live in the e-commerce, and they're owned by the e-commerce team. And then the actual shoe store has its own scope, and anything that's very specific to the shoe store will be owned by that team, and that's in that scope. Now, every scope can have its own repo. So in GitHub, my project looks like this. I've got the base UI, which are just base UI components in a GitHub repo, the e-commerce, which are just e-commerce components in a GitHub repo, and then I've got 4 stores, because I wanted to build 4 stores, just to show you what it's like. And they're all in their own separate repo. So pretty much, you should be able to look at your scopes and actually see how each of them are connected. You can see the dependence of each one. So you're able to kind of like see, okay, this one depends on the base UI and on the e-commerce. This one is feeding all these components, all these other scopes. And basically, you can see at all times what's going on, who's using what, and who depends on who. This gives you better control of your scopes. So you want teams, basically. Now, in my example, you saw my photograph there on every single one. And that's just because, like, I have no one on my team. But normally you would have like different people and you'd have different teams own them. So that's how you would do it. But you could also have teams owning more than one scope. That's also totally cool. So yeah, you want your teams to own those features. They're going to be happier, believe me. And you want them to work independent from the other teams. So you want to be able to build the e-commerce components completely separate to the shoe store and deploy those components and not care about what the shoe store is doing or what the base UI team is doing. And you want to have separate build pipelines. You want to build it, test it, and deploy it. You want to test it independently from every other one. That's what they're doing is whatever, and ship them when you want to, which means you don't have to wait for something to be ready. You remember those Fridays? We're going to deploy on a Friday. You don't have to do that anymore. You're going to deploy when you're ready to deploy. And basically, teams want autonomy. Developers are very, very clever people. We're all very clever people. We want to basically just build, own it, ship it, and then like do the next task. So apps are composed from components, right? Now an app is a component. Everything is a component, not just like front-end UI components. Serverless functions are components. So everything is a component, right? And apps are then composed from the components. So this is, I know this is kind of probably hard to see, but basically this is like what my app looks like with all those components. And it's a very simple app when you actually see it, and I'll share the link later to it. But basically, everything is broken down into very, very small components. But at all times, you can see in the dependency graph what components are being used, what version of the components and you can kind of like scroll across and see the whole entire dependency graph of that actual app. So this is my application, and it's kind of pretty cool. I'm proud of it. This is my shoe store. If you want to buy shoes, the buy now button doesn't work, so don't try and buy the shoes. I haven't built that yet. But basically, yeah, this is the application, and how it's made up is, the logo is coming from the base UI. The e-commerce is coming from the e-commerce scope or e-commerce repo, right? It's in different GitHub repos. And the hero component is actually coming from the shoe store itself, because it's specific to the shoe store. So this is how the application is made up. So component-driven basically is a reuse-based approach to defining, implementing, and composing loosely coupled independent components into systems. And this is the key here, loosely coupled independent components. I mean, fully decoupled would be better, but sometimes you might have to kind of couple some things together. So loosely coupled and independent, you want them to be like, almost like every component is like its own mini repo or its own mini application, right? And it's fully independent and can be built and used outside of any other environment. So here's my shoes card. This is just an example. And how I built this card, for example, it's made up of the card. So the card is like, just an empty card, but it controls like the border, the shadowing, the rounded border, etc. So it's very simple. It's got children, you put whatever you want inside. And then the heading is a component. The text is a component. The image is a component. The button is a component. And the currency is a component. And you might just say, but isn't it quicker to just build a product card and just put all these things inside it, just like, not build like in components? And I kind of thought that, and it is a little quicker to just throw all your code together and then just like go on to the next thing. But you're not then thinking about scaling. You're not then thinking about how to build better. When the next person comes onto the team, they're going to struggle to kind of like, if you need to have another button component or the currency component. For example, my currency accepts dollars and euros at the moment. Well, what if we go to the UK? We might want the British pound in there. So now that currency is not a component and it's across multiple places in the application. You've got to update that everywhere. Then you've got issues where if it's in one place and you update it once, happy days, sorted. The same with the image component. Now you might say, why do I need to create an image component? That's just stupid. I'm just using an image tag, right? But Nuxt.js, for example, they just released their new Nuxt image, which is basically to be able to use the Nuxt image and you're going to have better performance, similar to Gatsby image or what Next have done. And now you've got this image component, and I've had to refactor my whole application to basically use that. And it's like a lot of work. So imagine that on a large scale application. So if you have one image component and now you have something like, Chrome have changed something or Nuxt.js have changed something, then you simply just modify that one component, update it, export it, version it, and everyone just consumes it. Easy. So this is like basically, you should be able to see at all times what your component is doing, where these components are coming from, how they're made up. So the design team can also kind of see like these are components. This is all basically separated into individual components and you can see where they're coming from. And the same, if you were to look at the dependency graph, you should be able to look at your dependency graph and see all your components and see like, for example, that card component that's coming from the base scope, they own that. So if you wanted a modification of that, you know which team to go to. If you want to modify the shoes card, you know it belongs to the shoe store. So you're able to say, oh, I need to contact that team, for example, and change the API or make an addition to something. And the currency component, for example, because now we want to accept the British pound. So I need to go to the e-commerce team and say, hey, I need to like add something to the API. Can you add this? Can you do whatever? So how do we actually build component driven, right? We're thinking like, oh, okay, maybe I can do this. How do we do it? We want to think about every component as a product for anyone to use. So you kind of almost want to think like you're building open source, right? Now, if you're building something for open source, you want everyone to adopt what you're building. You want everyone to use it, consume it, and you'll be happy when you get like all these stars and someone's using your component. And it's one of the hardest things, right? Because when you're building components at work, you don't want to use someone else's component, right? Because like, they're just going to do a terrible job and I don't trust them. And, you basically want people to trust you. You want to do a great job. You want people to use it. So your component basically should have a great developer experience. It should have different contexts. You should be able to use different themes, for example. to be able to use that component so it looks and behaves a little bit differently depending on what you want. It should be easy to use. You should know how to use it. You should be able to document it so people can see how to use it. The API should be documented so you know what you have available to you, what you can actually use and what's missing, for example. It should be loosely coupled, so you're not like coupled to some like big data store, for example. And basically, once you do that, your developers, us, we're going to write better software. We're going to write more maintainable software. We're going to write more testable software. And we're going to have a better developer experience. And our organizations are going to have better software. They're going to save time. They're going to save money because like that's all they care about, right? So they're going to save money because you've got all those components that you can just reuse various times. And they're going to have happier devs. And they're starting to care about developers right now because developers keep leaving to go to other companies. So if they've got happier developers, then, you know, people are going to stay and they're going to be happier. So it's a win-win situation. So to build component-driven, you got your components, and your components basically should be themable. So you should be able to reuse the components with different themes. They should be composable. You should be able to compose components from other components. They should be encapsulated, like it has everything it needs inside itself. They should be independent, so they can be built, versioned, and deployed independently. And they should be reusable, so you can reuse across any application or multiple applications. Sounds simple, right? So themable, I mean, we all know what themable means, right? Design the components with themes so they can be used in other applications in different scenarios, in different ways. You have the same component, you're just reusing it. Like my product card. So in the shoe store, it looks like this. And in the perfume store, it looks completely different because I've got a different audience. I want it to kind of look, you know, a bit different. But it's exactly the same component using exactly the same versions. The only thing is it's wrapped in a theme provider that just provides different colors and different styles. And that's it. So you want your components to be composable. So you want to compose smaller components together to form more complex components, such as the product card that I showed you earlier, which is built up of these 6 components. 6 components make up this one product card, and they are all completely independent and completely deployed and versioned independently. And you could add more if you want to extend that product card. You can add more components to it. And you want them to be encapsulated so that exposes the interfaces which allow the user to call its functionality, so button components, etc. You want to hide the details of the internal of the variables and states. So you want to basically just, you know, if you're using React, for example, props and everything, this is a title, a text, the source, the alt, these are all props and you have access to it to change it and to add to what you want. And then you can think like the currency. Will I allow them to put in any currency? Or will that be a disaster because we're only in 2 markets, so I'm not going to allow them to make a mistake, so I'm going to use dollar and euro only. But that's up to you. When you're building the API for that component, you have to think, what should I allow them to? What should I not allow them to do, etc. And then, yes, independent. I mean, we all want independence, don't we? So independent, your components also want to be independent. So let them be independent. They want to have their own version and they want to have their own revision history. It makes it easier to kind of work with that component. And you want them to have their own build pipeline, because when you're finished building that one component, maybe it's a big component like a shopping cart, you want to just deploy it and then you want to go home because you finished work early and you don't care the other team. They've got to work till 2 o'clock in the morning because they didn't do their job. That's not your problem. Independence. And then you want minimal dependencies on other components. So you don't want like, you can depend on the component in the sense of that you're using it, but you're not depending on it. Like if you take it away, you could reuse it, you could compose it with other components. And yeah, independent, basically, you can see like this one here, you can see all the versions I've got. The image is on version 1.0.11, the button's on version 2.0.3, and every single one can have whatever version. And then you want the components to be reusable, obviously. I mean, the whole aim of this is so that then later, when you scale, you want to be able to use that component again and again in different scenarios, in different applications, in the same application, right? So the button component, very simple component, but one component that's used across your application in so many places. Here it's used in the product card and in the hero component. And we can just place it in and use it anywhere we want. So when we create the component, you want to basically think, right, I want everyone to use this component. So this is my button component, and I've documented everything out. So everyone knows how it can be used. I've added my Figma design in, so designers and the product managers can see like it looks exactly like design, and a design make it change, I can automatically see it and modify it. I can see the API, what's available to me, so I know that this component is exactly what I want or not. And then like you want people to be able to see and, you know, what's this component like? What have I removed, disabled? I want to play around with it. I want to see like live how this is going to change as a link. So it works as a link as well. You know, designers that make buttons look like links and we have to make them, but they need to be like not buttons, but A tags. So this will do that for you. And if I was to remove that, it will remove the A tag and it will give me the secondary button, etc. And you want to see the different compositions. You want to create all these kind of compositions so people can see what it would look like and how it would behave and act in different scenarios. You want to see all the tests, and you want your tests to almost be like documentation features. And then you want to see, what does this depend on? So this button doesn't depend on anything, but it could depend on something else. And then you want to see the code, because you do trust the component, but you really want to see what the developer did and how they built it, and are they using, you know, TypeScript? Are they using Sass? What kind of CSS are they using, etc. And you want to see the versions. You want to be able to go back in time, check through the versions, because maybe your application's not ready to use the new version. Maybe you haven't updated to the new styling. So you should be able to go back in time, see the component in its different state with the terrible documentation that you wrote when you first wrote the component, and the ugly design when the designer hadn't designed it or when the design changed. And then you can use that. You can actually use that version, or you can use the latest version, but you choose which version of the component you want to use. And you can see like, yeah, this is much nicer. That's what my designer gave out to me and said, Debbie, your designs are terrible. I was like, I know. And then you can use that component and just use npm or yarn, basically take it and install it into your application. So any of you can use my button component. It's open source. It's all yours. It's beautiful. And use it in any of your apps. So that means basically your application now, everything is decoupled, right? All your components are separate. You saw that one button component and everything is just decoupled. And that just makes it very easy to just like drop things in, basically. You're just building an application, you're just installing something and then just using it. And all my code bases are decoupled. So it's easier for me to manage these code bases. It's easier for me to take on new members in a team and say, right, you're going to work in the base UI team and you're responsible for all the components in that repo. And you don't even have to know that the other repo exists. It's just not even important. And that means you can work in a monorepo if you want to. So the two people that love monorepos, you can still work in a monorepo. All your components are versioned. So it just works exactly the same. For those that don't like monorepos, you can still work in multi-repos and have everything in different repos. Or you can work as how I work, which is just decoupled code bases where everything is just decoupled and everything is its own repo. And that's completely up to you and how you build your teams and what is easier to work with. So it's not like you have to work this way or this way. You work whichever way makes sense for your team, for your organization. And you know, sometimes you can start out as one monorepo and then kind of actually you're better off now as a team because this has basically grown to be so big, has so many components. So let's separate it out and let's create its own. But what's important is the scopes. How you scope things is very important because that comes with package naming, etc. So changing the scope later on will break everything if you have to change your package name. So think about your scoping. That's very, very important. But how it lives in the repos is not important. That can be changed, which is kind of cool. So yeah, this is just basically an example of my scopes. And this is my base UI. These are my components for the base UI. I've got another one, which is a movies scope, and they're the components from the movies, the components from the e-commerce, for example, the components from the shoe store. So I can see at all times and, you know, search over them, find which component I want and use whichever one in whichever one I want. So that means we can compose components to create apps. That's all we want to do. We want to basically build apps faster. The project managers that come along, the CEOs come along. We need the app finished. We need another app. We need this. We need this. And it's now easy to do it because we have access to all these components. So we can easily just build applications. And this is my shoe store application. So basically then you can, go along here and you can see how it's actually built up. You can see the composition of that application and you can click on the highlighter there and actually see, right, this is coming from base UI. This is actually this component. So you can even take another application and kind of like study to see what component they're using. So when you want to create another application, then you know what components you want to actually consume and use, because you're like, yeah, I like this product card component. This looks great. And this is coming from this scope, and you can find it, use it, consume it, etc. And anyone can also see how everything is composed together. So you want to reuse the components in any application. That's what we want to do. And that means I created like a store for headphones, my electronics store, with like all those components, exactly the same components, but it just looks a little bit different, and it's just got like different data. So everything is shared, even the entity component. So the entity component basically has all the types and the data types and the mock data, etc. And this is shared across all these applications. But then the shoe store, for example, extends it because it has different things like colors. Shoes are available in different colors, perfume isn't. So it just takes an entity component and extends it. And now I've got this new component that is extending another component, but that's another component that gets updated. I get the updated of even just that entity. So it's kind of like really cool. You have to think about how you want to work. And then that allows you to just decouple everything. And it just makes life easier when everything is decoupled. So component driven. Components are truly isolated. Really important. You want your components to be truly isolated. You want to be scoped to a particular team. So you want to think about your components when you're building them. What team should this component, who should they belong to? What is their scope? Think about that. It's kind of like domain driven a little bit, right? So think about the scope, who owns it, and then that's where you create that component. It should be independently versioned. Every component has its own version. It should be released independently, so you can build that one component, release it. And then it's no longer coupled to the app. Now, if you still want to build inside the application because you're happy doing that, that's what you did all your life, and that makes you happy, that's also cool. But now it can actually be used in other places. But if you're building it tightly coupled to the app and then you build another app, does it make sense to then still have it kind of belonging to the code base of the app? Perhaps not. So maybe take the components, put them in their own repo, and have them separate to the app, and maybe the app just uses them. Maybe you only have one app, but later you might have two. And then they can be consumed in the app, in any app, in many apps. And if you want to make your components public, which you can do, then they can be consumed by anyone in the world, which is also cool. It's open source. Sharing is caring. So if you build a great component, then maybe I can use it because you're better than me at building some components. And that's cool because then I don't have to work so hard. And any components I built, you can use. So this is also cool. But also you might work for an organization that's like, no, we don't do open source. We can't share anything. And that's also fine. So then you can just make all your components private and only people in your company, in your team can see it and have access to it. That's, up to you. So basically it's time to say goodbye to the monolith. You want to have your back end with microservices. Pretty much you're probably already there. And you want your front end to be built with independent components and not just one big monolithic application. If we do this, life will be so much better. Believe me, it takes time. Thinking about things, architecting things out takes time, but it's so worth it. And I'm not sure if you were here yesterday, but we were in this room. Michaela did an amazing talk. And one of the slides I stole from her because I just like what she said. And she said, today's developers are tomorrow's architects. And it is so true. So every single one of you today who are developers, you are the architects of tomorrow. And I'm going to get old and then I won't be around anymore. You're going to have to take over. So it's up to you to build a better software for the future. It's up to you to change things. It's up to you to propose new things to the product managers, to the CEOs, even to the other architects that have been working for ages and don't know about, new stuff. It's up to you to change the world and create better software. So you really do have to decode your space. And if you don't, these guys are going to come after you. So seriously, go and do it and go and create and build better software. Thanks for listening. And I do have the demo slide up there, but they took it off. So I'm not sure if they're going to put it back. So this is the QR code. So if you do want to actually see that project, you can scan that code. That will take you to where the e-commerce site is built. And there is a README component that you can go to. And if you open that, that will actually give you the link to the GitHub repo. So you can actually see that they are all in different GitHub repos. It's not just me talking about it. It actually does work. And you can even clone it, play around with it. You can take one of my components. You can just use yarn or NPM to install it, play with it, and basically just kind of check it out. So yeah, if you do have any questions, then...
Yeah, we have any questions.
Cool.
We have a few questions, at least online, and I think maybe something in the audience. I just want to note that, well, you can be a host and all the things I do other in life, which is all the creative and art, and understand this kind of stuff. This was so difficult. And every question I get online, every question I get online, I personally cannot understand a single thing I'm going to ask you now. So sorry if I pronounce something wrong, but we have a huge question from Ramunas. Let me put it on the table if I can.
Oh, that's like a book. They wrote a book.
Yeah, that's a paragraph. How to manage component versioning uplift in sync if they are dependent on other components due to being smaller parts owned by separate teams, and all components have to uplift their versions due to sharing backend, which is uplifted for all components at the same time. How to synchronize dependencies during this uplift for UI components? What could be the best practices and approaches?
Nice, you wrapped that really well. So basically, yeah, I told you at the start that I work for Bit. So that's basically what I'm using is Bit, and that's on bit.dev. You can check it out, which is open source, unless you want to pay money and use the cloud, but that's another story. You can just put it on a Docker container and you can host separate, or you can, but that's whatever. But basically what Bit does is it allows you to version your components completely independently. But if you're working in the workspace, so say the I don't know, the e-commerce scope, for example, and I'm using components that are used in that scope. So just to give you an example, imagine the product card and the button are in the same scope. Now, if I update the button to create a new version of that button, what's going to happen is I create the new version and it's going to know, oh, the product card uses that, and I don't know, the shopping cart uses it and something else uses it. So it's going to auto tag and auto update the components that depend on that needed that change. And that's inside that workspace. So you're controlling that workspace, that's your team. So that just, does it automatically and everything gets tagged to a new version. Then if you're in separate kind of repos, so like the button component is in the base department or the base scope, and the e-commerce is in the other scopes, and now they're in different repos, they're not connected. So now they can't auto tag each other. So then you update that button component, and then you have to pull down like you would in kind of NPM package, like you'd normally pull down a version and update that to the next version if you decided to want to use that version. Now you can pull that component in. You can use an import feature where you can actually pull the component in to another scope. You can test it then. You can play around with it. You can even modify it. Say someone broke something, you can change it, export it from, so tag a new version, export it from that scope, and then basically just eject it from your workspace because it doesn't belong there, it belongs to the base UI, and then continue working. Now there is a feature that we're working on, which is, we're using it internally, but it's not public yet, but it will be very soon, maybe in a couple of months. And that's like an automatic CI pipeline for the components, where basically when you update that button component, it's gonna give you a preview of that component, how it's affected wherever it's used. So for example, it's used in the product card, it's used in the hero component, it's used in the shopping cart, it's used in etc. And you'll get a preview, kind of like what Netlify previews do. I don't know if you use Netlify. They have a great deploy preview. So that kind of similar situation where you see how that component is going to look, and then you can kind of accept that pull request or not, depending on how it's simulated. And then it's updated for you. That's kind of coming very soon. But at the moment, it is a manual way that you have to actually install the package, install the updated version, if that's what you want to do.
So paragraph for paragraph. Any questions from the live audience, by the way? Yes, I would be afraid too. We have another paragraph, and one more just popped up. So wait a second. Okay. Can Debbie, again, explain the difference between component-driven and pushing components into components? Why am I saying components? It's Lithuanian. It's Lithuanian stressing. Components into NPM. It seems that the big difference is that this solution provides a website where all the docs are synchronized, but all the other drawbacks of NPM versioning, I don't know what he even tried to say, still apply.
That's it.
Boom.
Okay. So NPM is for packages, right? And we use NPM under the hood because NPM is a package manager and it's great at doing what it does. So we just use it. But independent components is not just the package, it's got everything else in it, like the source code and stuff. So that makes you then be able to, like I said, import that code, have access to the source code, be able to edit and modify it, and then export a version from anywhere. So your component is basically in a cloud and can be used anywhere in any single workspace by any team. Obviously, with team ownership, you decide who owns it and stuff. So there's a very big difference, but it's a great question because I actually asked that question myself to the CEO, and I was like, "What is the difference?" It's like it's a massive difference. But yes, basically, it looks kind of similar, and yes, we have a better UI than NPM, for example. But like we're still using NPM, and you can still push your components actually to the NPM registry if you want. Although I don't, but some of our components are in the NPM registry. That's up to you. But it's like NPM is being used by us because we're not a package manager. That makes sense.
Oh, not for me, but I hope. Honestly, I mostly understand what's going on in build stuff, but sometimes it's just...
I had loads of images in my talk. I should have been using.
I just don't want to even go there. You speak Spanish to me right now.
Okay.
I cannot understand a single word. Anyway, do we... Okay, we do, and you're so high up. Almost lost you. You were white, as in a sweater white.
Thank you. That was a really interesting presentation. But I would just, so that everyone has something to talk about, my question will not be technical, but what's your favorite Pro Tour cyclist? What brand of bike you ride, and how does that help you to become better at what you do at work?
So Movie Star, because they have a great thing on Netflix that you should watch. It's really, really good. Their team, like what they go through, oh my God, it's like crazy. My bike is not an amazing bike. So I won't even share that with you. It's not worth 3,000 euros or anything like that. But it is cool. And there's actually a video on YouTube if you want to see me cycling in Mallorca. They filmed me for a conference where I'm cycling down Sa Calobra, which is incredible. So we want to see the bike there. But yeah, what was the rest of the part of the question? How does it help you become better at what you do? Yeah, great. So basically, how it helps me be better is by going to the mountains and cycling. My fingers cannot use code. It's impossible to cycle and write code. So that helps me be able to like think things over, because if we're just sitting at our desk all day, every day, your mental brain is not getting a break. And if you are able to walk out the door, do something different, and especially be surrounded by nature and also do sport, it's a win-win. And seriously, like anytime I'm stuck, and I say this sometimes, but sometimes I'm like, actually, no, I'm not going to go out. I need to finish this. I need to finish this. I need to make this work. It's broken. No, I can do this. Like 5 more minutes, 10 more minutes, and 3 hours later, and it's terrible. So yeah, basically take some time out and go and do cycling. You will be a better developer. I will. You might be doing something else. It could be running. It might be just reading a book. It might be just going for a walk in the forest, but whatever. But do take out time for yourself, because personal health is very, very important. Don't just only develop. We're worth more than that.
Okay, any more questions from the audience? Not much. Then I have a question at the same kind of similar topic. Just what does it mean? Because I didn't know there were, levels of belts. Yeah. What does it mean, the fourth level of black belt?
So basically means that you've got to keep having another exam, and you get another kind of like thing on your belt.
So it's the bigger the better.
Of course,
okay.
Always.
Well, sometimes the first one is the best.
The first one is the hardest, and then you get there, and then you're like, oh my God, I'm just like a junior, because now like all these other black belts, there's like 9 levels, right? And I'm now level 1. So you kind of think you're at the top, and then once you get the top, you're actually at the bottom. Just kind of like coding, because you learn something. Like I learned, Vue and Nux, and I was at the top, and then I go to work in React, and I'm at the bottom, and I got to climb up again. So, it's kind of very similar in life.
Okay, now I know everything I wanted to know about you. If we don't have any more questions, I thank you very much for informative and entertaining somehow session. Much. Thank you very much. Yes, applause would be, a nice thing to do now.
Thank you. And if anyone does have questions, come and have a chat to me or reach out to me on Twitter. I'd be happy to answer. Thank you.